In 11.1, we're going to start by simplifying radicals. And I want to start with a little bit of review for you about what do we do when we simplify radicals. Okay, so let's look first at this number 1, the square root of 9. Remember that what we look at is we factor what's underneath down to the prime numbers and look for pairs. So since there's a pair of 3's, that pair of 3's can come out as a single 3. And that's it. Look at number 2. I'm going to factor that 75 down. Well, that's 25 times 3, or I could keep going, 5 times 5 times 3. Then I have a pair. That pair comes out as a 5, and I leave it as a square root of 3, what's underneath. Number 3 has a negative out front, so we're just going to leave that negative out there. Don't mess with it, just treat it like a negative 1. And let's look at what's underneath. Well, 8 is 4 times 2, right? If we keep factoring this down, we get 2 times 2 times 2. So there's a pair of 2's that can come out. Now I need to multiply that 2 that I'm taking out by the negative 1, so it becomes a negative 2 square roots of 2. Let's look at number 4. Cube root. Now this is different. A cube root means instead of pairs like we did before, we're taking out groups of 3. So on these previous ones, we could have had a little 2 right here. That little number is called the index, and we don't usually write the 2 because square root's the most common, but if it changes from being a square root to a cube root, you will see a 3, as you will in the next couple examples. So what's changing is instead of just looking for pairs like we did to come out, we need to look for triples. Only triples can come out of these. So let's try this one. So again, if I take the cube root, leave that 3 there, if I factor that 8 down, I get 2 times 2 times 2. That's a good one to memorize, by the way. 2 cubed is 8. Since there's 3 of them, I can take it out as a single 2, and that's it. Let's look at this one, negative 1, keep that negative out there, and then there's a cube root of 54. So let's just start breaking this 54 down. Well, I know it's 9 times 6. If you want to keep going, I know 9 is 3 times 3, 6 is 3 times 2, so there's a triple. I can come out, and I multiply it by that negative 1. So I have negative 3 cube roots of 2. That 2 stays under the radical because there's not a group of 3 to take out. Now, number 6, look at number 6. This one has a root of 4, so this means I have to find groups of 4 to take out. Leave the plus or minus alone, leave the fourth root there, and let's just start factoring this down. Well, 48 is 6 times 8. Keep going. That's 3 times 2. 8 is, we just said it's 8, it's 2 cubed, so it's 2 times 2 times 2. Here's a group of 4 I can pull out. So my answer will be plus or minus 2, fourth root of 3. All right, so that is basic simplification and maybe potentially introducing you to other roots, cube root and fourth roots. Okay, it could be anything, any root now. Now let's take this up to algebra 2. All right, here's the new piece of information that you may or may not have seen before. When you have variables under the radical, there's a rule you need to follow, and it says if an odd amount pops out of an even index, use absolute value. All right, now I'm going to break this down for you and I'll demonstrate it a few times for you as well. So here's the thing. If an odd amount comes out and I have an even index. Now what the heck is the index? The index is that little number right there on the square root. So on number 5 it was a 3, on number 6 it was the 4. On number 2 up here that was a 2. That's the index. Now odd amount is how many did I take out. So I'm going to show you what I mean and how you work these in the following examples. All right, look at this number 1. Now, I have an index of 2 right here, so that's an even index, so I may need to use the absolute value thing, so we'll come back and look at that. But let's start by just breaking down what's underneath. 48 is 6 times 8, And x cubed is x times x times x. Now, I won't always write this out, but I want you to see that I can take things out in twos, right? I can take that out, and let's keep going. I'll leave one x underneath, but let's keep factoring this down. Okay, so this would be 3 times 2. Remember, 8 is 2 times 2 times 2. And then we have this x, x, x. Okay, so we're taking those out. We're going to definitely take an x out, right? Now let's look at for pairs. We have a pair of 2's and we have another pair of 2's, right? So those pairs of 2's are going to come out as multiplied. So that 2 times 2 gives me 4. And I am taking one x out, and I'm going to leave under the radical the 3 and the x. Now remember the rule. It says if you take an odd amount of a variable out of an even index, you got to use absolute values. So look at my x. Did I take only one of them out? Yes. So I have to put an absolute value bars around that. This is what my final answer will look like. Let's try the next one. So this one has a 6 out front. Great. All right. It has an index of 2, right? 45 is 9 times 5, x squared, y to the 4th. Now let's think about this. 6 times 3 times 3 times 5. If you want to write it out, you can. You don't have to. Doing it just for this one example. So let's think about the pairs that we can take out. This 3 can come out, and we'd multiply it by 6. So 6 times 3 would give me 18. Let's see what else. I can take one x out. So that's definitely going to have to be in absolute values. But let's see. If I can take one y, two y's. So that means I'm taking out a y squared. So the x is the only variable that needs to be in the absolute value bar. So then what's left? The only thing left in the radical is that square root is the 5. So there's your answer. Looks kind of weird, but that's what your answer should look like. Let's try this one. Notice this one is to the 5th root. This is different, right? So it has to come out in groups of 5. So let's do some factoring. All right, so 486. I know it's even, so I can definitely take out a 2. If I divide by 2, I get 243. Then let's think here. Did you know there's a trick here that if you add up the digits, so 2 plus 4 is 6, 6 plus 3 is 9. If that sum is divisible by 3, then the whole thing's divisible by 3. Works great. So if I take out the 3, if I divide by 3, that gives me 81. Right? So if I keep on going with this guy, I have 2 times 3 times 81 is 9 times 9, right? So that's 3 times 3 times 3 times 3. Now I look at this. Do I have 5? 1, 2, 3, 4, 5. I do. So I can take a 3 out. I don't have any variables to take out, so I'm not worried about the absolute value thing. Plus or minus the 5th root of 2. And that's all this one is. This little rule only applies if it's variables. All right? Keep that in mind. All right, let's look at number 4. This is a 4th root, so it's the even power, the even index, so I may have to, and I've got variables, so I may have to deal with the absolute value thing. So we'll go back and recheck our answer when we get there. So if I need to take things out in groups of 4, so let's think through this really quick. If I listed out all these x's, there's 13 of them, right? And I need to take them out in groups of 4. So if I divide that 13 by 4, I can take out 3 with 1 left over. So I'm going to leave 1 here. So I'm going to take out an x cubed. Then with the y's, I have to take out groups of 4 also. So I could take out 2 groups of 4, and that would leave me, that would be 8 of them, and that leaves me 2 y's left underneath the radical. So if I take the 2 y's out, now I look at my answer, and remember the rule. If we take an odd amount out of an even index, then it has to be an absolute value bar. So here's an odd amount, odd power of a variable taken from an even index means I need to have absolute value bars around just the x cubed because that's the odd one, right? Y squared is an even power, so I don't need to worry about absolute value bars on that guy. Look at number 5. We'll keep doing this. This one's a cube root, so I need groups of 3. So I'm going to start by factoring the 72 down. I know that's 9 times 8. 9 is 3 times 3. 8 is 2 times 2 times 2. A cubed, b to the 4th. All right, let's take out groups of 3. Well, the 3s aren't going to come out. The 2s can come out to play, right? The A has a group of 3, so I'm going to take 1A out. B, I can take 3 away from that and leave 1 in. And it's still the cube root. What's left over? Well, I have 3 times 3 is 9. A is gone, and then there's 1B left over. Okay, on number 6, we have a 5th root. So we got to take things out in groups of 5. So let's look. Quickly what comes out to mind is this x to the 10th power. That means I can take 2 x's out, right? If I group them all by 5s. So I'll take x squared out. The y's are going to stay stuck because there's not even 5 there. But let's break down that 224. Now, obviously it's even, so I know I can divide by 2, but did you know there's a divisibility rule of 4 that says if the last 2 digits are divisible by 4, the whole thing is? So if I take out 4, I would get 56. And I've taken all the x's out, so y to the 3rd is going to stay. Now, I can keep going. I need to see what else is happening here. So that's 2 times 2. 56 is 8 times 7. So that's 3 2s times 7, y to the 3rd. Now I go back and look at, do I have 5 2s? 1, 2, 3, 4, 5. I do. So I can pop that out. So it's 2x squared 7y to the 3rd. And it's the 5th root, so I need to make sure I put that little 5 right there. Now, the question is, look at the variable. Did I take an odd amount out of an even index? Nope, it was an odd index, and I took an even amount out. So this is my answer. 2x squared times the 5th root of 7y to the 3rd. Let's look at number 7 here. So there's a negative 2 hanging out up front. It's the 6th root. So let's see, what can I take out? Let's do our exponents really quick. If I take that negative 2 out, look at my x to the 11th. If I take out 6 of those, that takes out 1x. That leaves me with 5 in there, right? Not enough to take it out. Y to the 18th, I can take out 3 groups of 6, so that's y to the 3rd that comes out. Now let's factor this 64 down. That's 8 times 8, so it's 2 times 2 times 2 times 2 times 2 times 2. Well, I need 6, right? 1, 2, 3, 4, 5, 6. That's all of it. So I can take a 2 out. So what does my final answer look like? It looks like this. Negative 4x, y to the 3rd, and then I have the 6th root of what's left over is x to the 5th. Now, let's look at this. Is it an even indexed root? Yes, it is. Did I take an odd amount of x? I did, and I took an odd amount of y. So the variable portion here needs to be in the square root bars. Okay, let's try number 8. All right, this is a square root, right, of x minus 3 squared. So if I take, this is like x minus 3 times x minus 3, right? Since they're in a pair, I can take 1 out. So it's still, I'm taking 1 out of an even root, so I have to put it in absolute value bars. And then lastly, number 9. This one's a cube root of all of this. Now, if you expanded this, you'd have to write this thing 10 times. We don't want to do that. It's too much work. But let's think about it. How many groups of 3 can we take out of 10? Well, you can take 3 groups of 3 out. And if I take out 3 groups of 3, that's 9. That means there's 1 left over in there. So I'm going to take out 3x plus 10, taking 3 of those out, but there's still 1 left over under the radical. And that's what my answer would look like, believe it or not. Looks like this. All right, I hope this makes sense to you, and let me know what questions you have when we get to class.